Hey guys, okay, if you will, in your table of contents, and I am on page 53, we're going to start our exponent rules. And a lot of these are going to have the same title, except we're going to just talk about which rule we're talking about each day. So for our first day of exponent rules, we're going to be talking about adding and subtracting. Okay, so that's your table of contents. And now I'm going to flip over to this, and I have some fill in the blanks kind of stuff. So if you want to go ahead and pause and write as much as you can, go ahead. We're going to fill in these blanks, and then we just have like 9 little examples that we're going to do. So a monomial is a number. A monomial is a variable. Or a monomial is a product of numbers and variables. Okay, so, excuse me. An example of a number monomial. You could have the number 53. You could also have the number -2. So those are 2 examples of a number. An example of a variable monomial would be like x squared. Or we could do y. Either one of those. Okay. Now, an example of a product and of numbers and variables. So now what you're doing is you're putting the 2 together, and product means you're multiplying. So I could take this 53 and this x squared, and I can put them together, and that is still a monomial because it's one piece. Remember, if you look at mono means one. There's nothing splitting it up like a plus or a minus sign, so that's a monomial. Now, another example, you could do 3x squared y squared. That would be a monomial. You can have as many things in it as long as there's no plus sign or minus sign splitting it up. That is a monomial. So now a monomial with the same variables and exponents are what we call like terms. And you'll have heard this one before. So this is kind of a review today, but it's a review that needs to be done. So when you're working on the adding and subtracting rule, what you must do is to add or subtract monomials, you're just going to combine like terms. You're looking for things that look alike. Okay, this is such a key important thing right here. Do not change the variable or the exponents when you're adding or subtracting. They stay the exact same. Okay, now I'm going to move this down, and I'm going to go ahead and show all the examples. So if you would like to, you can pause and write all the examples so you can do them at once with me. Or if you wanted to try them on your own, you could. Oh, excuse me. Okay, so for our first example, we have 17x minus 25x. So what you have to do is make sure that they have the exact same letters. Since they are both x, all you're going to do is 17 minus 25, and 17 minus 25 is negative 18, and you always keep the letter because remember I said do not change the variables. I didn't have exponents on this one. Okay, for example 2, I have negative 15 a to the third bc plus 6a to the third bc. So you have to look at the letters as a whole. Are the letters in the exact same order, same exponents? A3bc. Yes, they are. So what you're going to do is you're just going to add the numbers. So negative 15 plus 6, which gives me negative 9. And I do not change the letters or the exponent this time, and that's my answer. Okay, for 3, I have 2ab plus 9ac. Okay, first thing I gotta do is check my letters. I have an AB, and this is an AC. Since the letters are not the same, I cannot combine the numbers, so my answer is 2ab plus 9ac. The only way you can add is if they look the exact same. Okay, for 4, I have 38x squared y minus x squared y. Okay, I look at my letters. They're x squared y's and x squared y's. So I'm going to add in a coefficient right there. And what I am doing is 38 minus 1. 38 minus 1 would be 37. And I do not change my letters or my exponents when I'm adding or subtracting. Okay, moving to example 5, I have 13w squared plus 9w plus 4w squared minus 31w. Okay, I'm going to start with my w squareds. I have a 13 and a 4. 13 plus 4 is 17w squared. The reason I didn't put the w's with the w squared is because you have to have like exponents. So a 9w and a negative 31w go together. So you're doing 9 plus negative 31, which is negative 22w. And you do not change it to a squared. You have to leave it as w. For example 6, I have 10m squared n plus 7mn squared minus m squared n. So the first thing I'm going to do is look at this m squared n. Okay, the next one's not an m squared n, so it does not go with it. But the last one is an m squared n. So the exact same order of letters go together. And so this is saying 10 minus 1. Well, 10 minus 1 is 9. And then I just keep m squared n. Okay, now I look at my mn squared, and that's the only one I have. So I'm just going to bring it over and do 7mn squared. And that's my final answer because these two things don't look alike, so they cannot go together. Okay, now for like a word example. Find the difference of 10x squared y and 2x squared y. Okay, keyword right here is difference. If we're doing difference, that tells me I'm taking 10x squared y and I am subtracting 2x squared y. Okay, since my letters are the exact same, I can go ahead and subtract these and I get 8x squared y. And there's my final answer. Okay, number 8 can be a tricky one. It says subtract 9a from 15a. That word from tells you that 15a comes first and we are subtracting 9a. So I'm taking 9a away from 15a. Okay, since these are both a's, they will combine, and 15 minus 9 is 6, and I keep my a. Okay, for my last example, which you're going to probably have more examples like this today, we have 2x squared plus 4x minus 6x squared plus 9 minus 6x plus 3. Okay, the first thing we have to do is distribute this negative 1. So that gives me 2x squared plus 4x minus 6x squared plus 9. And now I have a negative 6x because negative 1 times 6x. And I have a negative 3 because negative 1 times 3. I'm going to start with my x squareds. I have a 2x squared and a negative 6x squared. 2 and negative 6 make negative 4x squared. Then I'm going to move to my x's. I have a 4x and a negative 6x. A 4x and a negative 6x make a negative 2x. And then the last piece I have is 9 and negative 3. 9 and negative 3 make a positive 6. Since none of these have the same letter or anything like that, this would be your final answer for number 9 because nothing else will combine. Okay, so now y'all are going to start your activity, and if you have any questions, please let me know.